In this video, we're going to be talking about chain rule. I'll go over a similar questions on number 2 and question from number 4 and 5 from your homework on chapter 15, section B. So let's talk about a chain rule first. We use chain rule when there is a composition of two different functions. So if we look at number 2a, y is equal to 4x minus 5, the quantity squared, here we have two really different set of functions. The first function could be g of x is equal to x squared, and f of x is equal to 4x minus 5. So if y is equal to g of f of x, we plug in f of x, which is 4x minus 5, and then we plug in all the x's in g of x for 4x minus 5. So we have 4x minus 5 squared. So how do we use chain rule? First, we're going to differentiate like we normally do. So if you're given y is equal to some kind of function, raise it to the nth power, then the derivative of that function would be bring down that exponent in front of the function. So we'll have n of f of x, and then subtract the 1 from the exponent, then multiply this whole thing by the derivative of what's inside the parentheses. So derivative of f of x is what we're going to multiply. So that's basically the chain rule. So let's move on to our questions. Right. So here we're going to find the gradient of the function dy dx for y is equal to 4x minus 5, the whole thing squared. So derivative of y is equal to, bring down the 2 in front of the parentheses, so we have 2 times 4x minus 5, 2 minus 1, which is just 1, so I'm not going to write that, multiply by the derivative of what's inside. Derivative of 4x minus 5 would be just 4. So we have 2 times 4, that's 8, and then 4x minus 5. I would normally accept this answer, but if you want to expand it, that's fine with me. 4 times 8, that's 32, x minus 40. Let's move on to the next question. Here we have y is equal to 1 over 5 minus 2x. We can write this as a non-fractional form. As you can guess, it could be 5 minus 2x to the negative first power. And then we would differentiate. Y prime is equal to, again, bring down this exponent in front of the parentheses, so we get negative 5 minus 2x, negative 1 minus 1, so makes it a negative 2, and then multiply that by derivative of what's inside, so negative 2. So if you multiply negative times negative 2, that makes it a positive 2, 5 minus 2x, raise it to the negative second power. So this is a perfectly fine answer. However, let's say you wanted to put them back onto the fractional form, then it would be 2 over 5 minus 2x, raise it to the second power. Let's move on to the next question. Here we have y is equal to square root of 3x minus x squared. So let's rewrite this as 3x minus x squared. Raise it to the square root is the same thing as raising it to the half power. So let's differentiate this one more time. We have half, bring it down, and then we write what's in the parentheses. Then take the derivative of it inside. Derivative of that would be 3 minus 2x. Let's move on to the next question. So here we have the gradient of the function f of x is equal to 2x minus b raised to the 8th power, has a derivative 24x squared minus 24x plus 6. So find the constant a and b. First, find the derivative of f of x, which is f prime of x equals to, bring down the power a in front of the parentheses, so we have 2x minus b, raise it to the original power a minus 1. But don't forget, we have to multiply by the derivative of the parentheses, which has to be just 2. So we really have 2a parentheses 2x minus b raised to the a minus 1. And let's look at what's given as our derivative. You notice in here that they have 6 in common in all those three terms. So we can pull out the 6 and have 4x squared minus 4x plus 1. And then, I hope you notice, this can be written as a perfect square, which is 2x minus 1 squared. So let's compare what we just found and what we found here. So we have 2x, that's same. So b must be 1. And then a minus 2 has to be 2. So that means a has to be 3. We can sort of check our answer. If you plug it back in the 3 in here, you get 2 times 3 is 6, which is what we have. So the answer must be a is equal to 3 and b is equal to negative 1. Suppose y is equal to a over square root of 1 plus bx, where a and b are constants. Find a and b given that when x is equal to 3, y is equal to 1, and dy over dx is equal to negative 1 over 8. So here, let's plug in the values that we know. When x is 3, y is equal to 1. So 1 is equal to a over square root of 1 plus b times 3, that's the same thing as 3b. Then let's solve for an a. 1 is the same thing as 1 over 1, so we can cross multiply and say a is equal to square root of 1 plus 3b. Alright, looks like we need to take the derivative of y, so let's rewrite the y in non-fractional form. So we have y is equal to a times 1 plus bx raised to the negative half power. So taking a derivative of y, we'll have bring down the exponent, so we have negative a over 2, and then we have 1 plus bx, negative half minus 1, that would make it negative 3 over 2. And then don't forget to multiply by the derivative of what's inside the parentheses, which is just going to be b. So let's rewrite this a little bit nicely. So we have negative a all over 2 square root of 1 plus bx whole thing to the cube. But we know, because it's given in the problem, that dy over dx is negative 1 over 8. We also know that x is equal to 3. So let's plug in negative 1/8 is equal to negative ab all over 2 square root of 1 plus 3b raise it to the third power. Then we notice in here that we solved nicely for what a is equal to, which we're just going to plug in here. Need a little bit more space. So smaller. Right. So here we're going to have negative 1 over 8 equals to negative a, which is 1 plus 3b, times b all over 2 square root of 1 plus 3b to the cube. Let's remind ourselves with a little bit of algebra. If you have a square root of x to the cube, that's the same thing as x times x, which we can put these two things together, take it out of the roots, and say x root x. The same idea will apply in here if you have square root of 1 plus 3b, raise it to the third power. That's the same thing as 1 plus 3b, take it out, and then putting it under square root of 1 plus 3b. So let's rewrite this guy. We have negative 1 over 8 equals to negative square root of 1 plus 3b times b all over 2 times 1 plus 3b, and then we have that square root of 1 plus 3b. Now you probably have noticed that we can cancel out these things in here, and also we can cancel out the negatives in here. So we'll make it a positive. Negative divided by negative is a positive. So we have 1 over 8 is equal to b all over 2 times 1 plus 3b. Then it's really your preference how you want to carry out this equation. You can multiply by 2 on both sides of the equation and get 1 over 4 is equal to b over 1 plus 3b. And then you can cross multiply, so you get 4b is equal to 1 plus 3b. Move the b's onto the other side, so subtract the 3 b's on both sides. So I'm going to be left with b is equal to 1. So we are almost there. Going back to what we boxed in blue, since we solved that b is equal to 1, now we can solve for a. So a is equal to square root of 1 plus 3 times 1, which is just 3, which is a square root of 4. Again, which is 2. So in this question, a will be 2 and b will be just 1.